I think you are meeting Shivam Dubey for the first time, right? Maybe you guys can introduce yourself.
Hello everyone, myself Shivam, and I'm friend of Dhananjay, so I reached out to him. So he invited me here, so I'm very excited for this.
Welcome
Hi,
back.
Hi.
hi Shivam, I'm Tejas. I'm currently working as an intern in data science field, that is data analyst role. Yeah, nice to meet you.
Hi, Shivam. I'm Shalini. So, who I know Dhananjay through Purnima, and that's how I just start joining these sessions. It's been very nice so far. Yeah, good to meet you.
Hey, hi Shivam. This is Anup, and I know like I joined this platform through Jananjay only, and just trying to understand this data science and machine learning space. So I'm completely new to this field. Yeah, basically I work for a Citco group like as a vice president, taking care of intelligent automation practice. Yeah, thanks.
Okay, guys. Then maybe we can start.
Yeah,
So, slideshow, statistics lecture one. You are all able to see my screen, right?
yes.
Okay. Why is it not? Okay, now it's going. The second page, right?
Yeah,
Hi everyone. So let's start with the definition of statistics. It is the science of collecting, organizing, and analyzing data to make better decisions. I think one of you is. Can you mute everyone? And
yeah,
whenever you want to speak, maybe you can speak. There is some
uh,
sound coming, I guess.
yeah. Dhananjay, have you started the recording?
Yes, yes, I have started the recording.
Okay, okay.
So all the processes and please try to ask questions in between itself so that it's like a discussion session. As we all know most of the things that we will be discussing today, but the idea is to clear all the concepts. So it is the science of collecting, organizing, and analyzing data to make better decisions. So what is data? Uh, these are like facts or pieces of information which are measured, collected, or analyzed. Can you guys give some example of data?
Data could be in any format, like maybe um, in tabular format or maybe the structured. So we usually segregate the data in structured and unstructured format. So like the
Mm-hmm.
structured format, maybe they're in the tabular format, where we'll have the data in rows and column, so that
Mm-hmm.
like it can be easily read, and input data we can use it from the various sources to the various sources, like it can travel also. And unstructured data like maybe like some voice based data, some image based data, even like data which is not static but dynamic, like it is getting changed. So data could be in any form.
Yeah, right. Even it can be in tabular form, it can be an image, voice, text, anything can be data these days. And as Anup mentioned, it can be structured or unstructured. So actually, statistics also involves prediction. So the definition is actually wrong. So it is the science of collecting, organizing, and analyzing along with the inferring the data. So be careful with all the things that I say. I hope you guys will be asking more questions.
Yes.
Yeah. Uh, Broadly, there are two types of statistics, descriptive and inferential. Descriptive means making data understandable. And how can we do that? Can one of you like look at a few columns of the data and try to infer something from this data by reading out few cells of the data or one row of the data. Maybe Tejas.
Yeah, so we have an Excel format of data here.
Mm-hmm.
So there are about eight columns, and we have number of rows,
Mm-hmm.
and so the columns are age, gender, the job, housing,
Mm-hmm.
whether it's a saving account,
Mm-hmm.
credit amount,
Yeah.
duration, purpose. Yeah.
Any idea on how we can make this? So this is like so many rows, right? So if you read one row, there is no much information that you get. Even if you read 5 rows, there is not much information that we get from the data. We have to make it more understandable. uh, so how can we do that? How can we describe this data? Any example that you have? Anyone?
We can connote it in categorical values like male and female. We can assign for male 1, female 0, like
Mm-hmm.
that.
Yeah, but how to get an understanding of like what is like some data about okay, somebody, sorry. Yeah, so how to understand more about this data? Maybe you can use some describe this data better. Maybe like how many number of males are there, how many number of females are there, what is the average age. So how to describe this data? That part is known as descriptive statistics. So there are like measures of central tendency, measures of dispersion, how the data is distributed using different charts, and some summary statistics. So inferential statistics is the statistics that deals with making predictions or inferences from the data. So population and sample. Can someone define what is population and what is the difference between population and sample?
Population, it includes a large number of people
Mm-hmm.
living in a region, and sample could be collecting a certain amount of population
Mm-hmm.
and finding any patterns.
Yeah. So population is actually the complete set of the data, and from that we get a sample of the data. That is called the sample, and we will be further discussing about how to get a good sample to make good inference. So idea is to get a good sample and make some conclusion inference about the population from the sample data. So population is the complete set and sample is the subset, and characteristics which are part of the population are known as parameter, and this characteristics that are part of the sample is known as statistic. Now let's look at sampling design. How we can design the sampling so that we get better samples. So broadly they are divided into probability sampling and non-probability sampling. So anyone have any idea about what is probability sampling? Poonam? Okay. Am I audible actually?
Yes, you are audible. Like I can understand the probability, but in this regard, like probability sampling, like I'm a little confused, like
Mm-hmm.
in this terminology.
Okay. So probability sampling means every data point has equally likely chance of getting selected. There is no discrimination, and it's a random sampling process, and every data point has equal chance of getting selected. But that is not the case in non-probability sampling. So in probability sampling, there are more other techniques depending upon the data or the population. Simple random sampling is when we randomly select people from the population, but each one of them is has equally likely chance of getting selected. Can somebody give an example for this? Like when everyone has equally likely chance of getting selected.
A lucky draw, maybe.
Yeah, right. Yeah. And sometimes simple random sampling might not work because there are different sections within the population that has some particular characteristic. So if they have one particular characteristic, then that is called strata. So here we can say simply the people are of different characteristic. So each of them is denoted by different color, and then in stratified sampling, what we do is first divide each of the population into different groups, and from each of those groups we do random selection. But one more thing that we should note is depending on the size of the strata, each strata, it should be proportionately selected, but in this image it's not proportionately selected. But most of the time, depending if this particular session is very less, then we might be selecting fewer number of people. Can you give some example where the population has like a different characteristic, and we might need
Male,
to
female,
do
gender
stratified
wise,
sampling?
gender wise, like male and female.
Yes. Any other example? Maybe age. We can divide them into different age groups and select. Uh, Suppose people coming into a retail store, maybe. So some people, a certain age group might be less. The number of people from certain age group might be less. Maybe if you are going to studio, so most of them might be teenagers, but there are people of the other age group, maybe 30 to 40 also coming, 20 to 30 also coming. So if you do a sampling where equal number of people from one group is selected, so the teenagers we might be not be selecting more number of people. So depending on the type of problem, we should select the sample. Okay, then another type of sampling is systematic sampling. So in this, what we do is first we define the population, then decide on the sample size. How many number of samples do we need? Then we estimate the population size. Uh, so we know the population size and divide by sample size, we will get an interval. So we will select member every kth member and collect the data. Suppose people are coming into a shop, and they want to get feedback. So they know that in a month maybe 10,000 people come to the shop. So they decide a certain 10,000 divided by maybe 100 people they need. 10,000 divided by 100 would be 100. So 100 people they need. So every 10th member they will try to get a feedback. When not to use systematic sampling. So if there is any while using systematic sampling, if there is any periodicity or cyclicity associated with the data, then we should not use systematic sampling. Suppose there is a every 10th member is having maybe similar characteristic, then we shouldn't choose in that way, and that might not be representative of the population. So each type of sampling should be depending on our need, and we should think about how to do the sampling. Cluster sampling. So by looking at this image, do you guys have any idea, do you understand anything about cluster sampling? What do you see from these images?
uh, Data of the same characteristics have been taken into consideration.
Yes, so each of these individual clusters are having same characteristics. So suppose there are offices of TCS, maybe multiple offices within Bangalore. So they want to conduct one survey, so each of them have like similar number of employees, all those things, and same similar age group. So what they can do, instead of going over 10 offices, maybe they can take the sample entire sample from 3 offices, and then look more into the data. That is known as cluster sampling. Now let's look at non-probability sampling. Convenience sample. Uh, so here you can see in this image, is there any particular characteristics that you can understand from this image um, about convenience sample? Okay, maybe I'll explain. So in convenience sampling, based on the researcher's convenience, he whoever is near to him, he just takes sample. It's for an initial research about the data, not like very deep into the data, but suppose you are in a suppose today I give you a feedback form or a survey to you guys about people who want to learn data science. That is like a very convenient sample for me. I'm not taking into account of so many other people uh, who are also interested in learning data science, so their thought might be very different. That is known as convenience sample. And purposive sample, I'll explain through an example. I'm also a bit doubtful about this. So in this if we know about the population, we are an expert, then in that case we can use a purposive sample. The example they have given is suppose you want to suppose in a college you want to ask people who are physically disabled what are the different uh, accessibility options that they might need. So since we know about the population, we can actually ask people who are need different supports. Suppose one in a wheelchair might be needing one type of support, so we can select one person who needs a wheelchair. One who is blind might need another kind of support. In that case, what we can do is get a feedback from a person who is blind. Similarly, uh, we do that. And what is snowball sampling? In snowball sampling, it's very hard to get access to the population. In that case, what we do is we get a survey from one person and then ask him for help to get data from other people. uh, Suppose there are like so many homeless people, so there is no data about who is homeless and who is not homeless, but a person who is homeless might be knowing people who are homeless. So what we can do is give some survey forms to this person and ask him to get more surveys. So that's known as snowball sampling. And quota sample is when uh, we decide on how many number of people we want from each subgroup, and then select people. And there is also another type of sampling known as voluntary sampling. So here I have posted an image of iPhone 15's reviews. So here voluntarily people are giving reviews. So this is also a data, and they also have given ratings. But do you find any peculiarity of people who might be giving reviews? Does everyone give a review? No, right? So people who might be very feeling good about the product or bad about the product might come and give reviews. So that is known as voluntary sampling. So this is also leads to bias called voluntary bias. So here it's not actually representative of the entire population of people who might be using iPhone. So any doubt till now regarding all the types of sampling, like simple random sampling, all these types of sampling methods? Do you guys have any doubts or questions?
No doubt.
Okay. So as we can see, we have seen in the different sampling methods can lead to different types of biases. So one of them is called selection bias. So if when we are doing simple random sampling, right? If there are particular populations of people that are within the population, and we might be selecting people from only few subsets. So in that case, it will lead to a selection bias. So non-response bias. Sometimes people, due to the type of how we ask people the response, people might not respond to it. Like suppose you ask a question at maybe 4 p.m. So everyone might be traveling back to home, and it's the time window is like till 5 p.m. Everyone might be traveling back from office to home. So that in that case only few people will respond, and that is not actually representative of the population. That is known as non-response bias. And voluntary response bias, can one of you explain what is voluntary response bias? I have already explained it. Like in the iPhone example I have explained.
So voluntarily, for example, giving a review of the product,
Mm-hmm.
and it might be based on a single person's
Uh-huh.
um, decision.
Mm-hmm.
So it might not include everyone's decision.
Uh-huh. Everyone's, yeah,
Yeah,
opinion.
yeah.
Yeah, cool. So we are so we already discussed about parameter and statistics or estimate. So what we are trying to do using sampling is to get an estimate, uh, understand the parameter of the population by sampling. So actually the parameter that we calculate might have some bias. It has some bias. It's not. Then it might have chance error and the estimate from the population. So how can we reduce chance error? Any idea how we can reduce the chance error while calculating the parameter?
What is chance error?
Chance error is so the sample, right? The sample is actually not representative of the population. We are selecting only few number of people, few number of data points from the actual population. So it might not include everyone from the population.
Okay, okay.
So what we can do is have more data points or have better sampling methods. But chance error can be reduced by increasing the number of sample data points. But bias is due to the method of sampling. So if we increase the number of data points, chance error might reduce, and it can be estimated as well. But bias is a systematic issue, so it cannot be solved using increasing the number of data points. And data data can be uh, quantitative, that is numerical, or qualitative, like categorical. It's yeah, it's self-explainable, like discrete whole numbers which are positive. An example is number of children. And any numeric if it's data is continuous, any numerical value, weight. So these things you guys already understand, I guess. And yeah, so this is one or two terms that I wanted to discuss. So control group, when we are doing experiments within the data, right? So there are these two terms known as control group and treatment group. So these terms actually make sense when we think about doing some experiments within the population. So suppose there is a treatment for a corona. In that case, we get a group of people from the population, that is sample from the population that is representative of the population, and divide them into control group and treatment group. And what we do is, there will be team of researchers, then there will be these two sets, and we give medicine tablets to both of them for the disease. But one will be actual medicine, other might be just sugar tablets, but both will look similar. So the control group would be given the medicine, but it is not actually effective. But the treatment group will be given the actual medicine. The why we do this is to understand the placebo effect as well. So you know about placebo effect, right? So sometimes without medicine also, if we feel good, okay, we have received medicine or something, we are become positive, and that sometimes that disease get cured. So here, in order to avoid so both of them will be having placebo effect, but we want to separately study the treatment group. So even this type of experiments are conducted double blinded. The researchers, the control group and treatment group, don't know who will be given the actual medicine. So this is known as randomized control experiments. And inferential statistics, these are definitely we have to look into all of this, like hypothesis testing, p value, confidence interval, statistical analysis test. But inferential statistics we will be covering in the next week. So descriptive statistics, one second. So measures of a few descriptive statistics I'll explain. Measures of central tendency. Measures of central tendencies are statistical metrics that describe central point or typical value of a data set. Mean. You all know what is mean. Can you, one of you, define mean?
Mean is the average value of the data points.
Yeah, of the data points. Correct only. Thanks, Shubham. So, mean is the average value of the population or sample. So there are like population mean and sample mean. Here, it is represented by different variables. So it's self-explainable. So in order to describe data, uh, we use mean when the data is normally distributed. Otherwise, we will be using other measures of central tendencies. Median is a middle value in a data set when the values are arranged in ascending or descending order. If you arrange data in a particular order, if the central value is known as median. Mode. What is mode? Can one of you define mode?
So a data which is having the highest frequency, it's called as a mode.
Yeah, right. So depending on the type of data, so mean, when we use mean to describe a data when it is normally distributed, and if it's categorical data, we might use mode. And if it's negatively skewed or positively or right, or this is right skewed or left skewed, then we use median. So these are actually can be used in imputing data. So if we have some within the tabular data, right, if we have some missing points in particular feature, if the data is normally distributed, then we'll use mean, and if it's right skewed or left skewed, we'll use median, and if it's categorical, then we'll be using mode. Then measures of dispersion. This actually describes the spread or variability of the data set. They indicate how much the values in a data set differ from the central tendency, that is like mean, median, or mode, how they differ from the measures of central tendency. So we can use different, one of them is range. Range is min value to maximum value. What is that difference? Actually, it should be max value minus min value. Sorry. Then variance. Variance is how variance is the sum of all the differences, square of the sum of all the individual data points with the mean. And standard deviation is the square root of variance. So why do we mostly use standard deviation when we have variance? Can anyone of you answer that? Why do we use standard deviation when we are talking to people rather than variance? Anyone have? It's very. Think about it. Look at the formulas and try to answer this question. Why will we use variance, and why will we actually, when we are talking to someone, we will be actually telling about its standard deviation, not about its variance.
Uh, I'll try to answer this.
Mm-hmm.
So in standard deviation, we take a root of variance, and we actually get to know that how far it is from the mean value, because that is what I can see.
Yes, yes. So while squaring, this will actually have a value which is quite different from the actual mean or actual data. So by using standard deviation, it comes into the range of the actual data by taking square root. It will be having similar units as well.
Yeah, yeah, yes.
Yeah. Thanks, Shubham. Then let's discuss about percentiles and quartiles. So percentile value of x is calculated by number of values less than x by total number of values into 100. So by reading this, can all of you find the percentile of 9, calculate and find the percentile of 9?
Yeah.
Yeah, you can please.
Seventy five.
I also haven't calculated, so I hope it
Yeah.
matches with someone else's answer.
Yeah, even I got nearly around 73. Like,
Mm-hmm.
yeah.
Yeah. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 9, 9. 9 divided by 12. It should be 75. No? Number of values less than x divided by total number of values. Okay. Okay. Uh, so we will also discuss about find number summary and how to find remove outliers. So we discussed about okay. So I'll explain this through a code. So this is box plot. It will have median. Uh, it will have the 25th percentile value, 75th percentile value, and this minimum and maximum are calculated using Q1 minus 1.5 IQR interquartile range. Shalini, you were showing this on the data set, right? In the car data set that you were explaining, right? About how to remove outliers. So here we can see in this original data, we will calculate the 25th percentile value and the 75th percentile, and sorry, so Q1 comes out to be 16.5 and Q3 comes out to be 32.5, and then we calculate the IQR. It's like difference between Q3 and Q1, and then we calculate the lower bound and upper bound. Here the lower bound comes out to be minus 7.5, which is outside this, and the upper bound comes out to be 56.5. So in the previous image you see, right, this is minimum value, we calculated the maximum value, and we have the IQR. So now what we do is we have to remove the outliers. So within the lower bound and upper bound, we filter the data, and then this was the original data, and we have calculated the upper bound to be 56.5. So 100 is an outlier here. then we remove 100 from the data and we will be working with this much data only. So that's how a removal of outliers is done. I also wanted to cover probability, but I couldn't complete the slides for it. So, do you guys have any questions about this lecture?
So this IQR removal of outliers is just one, depending on the problem, again, we'll use that method of removal of outlier, right?
Yeah. So we will calculate uh, minimum, maximum. So in this code I have explained. So we have the original data. We find the 25th percentile value, 75th percentile value. Then we calculate the IQR, that middle portion. Then we will find out the lower bound and upper bound. So whatever is beyond the lower bound and more than upper bound, we consider them as outliers.
Yeah, got it. Like I meant to ask, is this the method that's usually used, or
I hope
it's
so.
just one of the ways to remove
Uh,
outliers, right?
I'll have to see. This is
Okay.
one way I have seen.
Okay.
We also plot and see
Okay.
sometimes.
Yeah.
Any specific reason why 25th and 75th percentile is used, or we are trying to get the values in between them? Is it so?
I'll have to see about that. I'm not sure.
Okay, no problem.
Mhm. Yeah, maybe one of you can ask GPT to get that specific answer and we can discuss now itself. Let's ask. Reason for using 25th and 75th percentile in box plot. Okay, network error. It just tells that it's actually summarizes the data well. That is why we use 25th and 75th percentile. Okay. Any other question? And next week, anyone want to present uh, something? Does anyone want to present something that they have learned recently? I have asked Adira to present the further inferential statistics parts, but it seems like she might be busy next week also. Mm, I am also traveling to Mumbai, so I'll be attending the session but might not be able to present. Anup, are you ready with that RPA presentation?
Dhananjay, I would love to, but for me also, like there is a back-to-back travel plan, like for every week.
Mm-hmm.
So another 4 to 5 weeks, I'm completely occupied, like with a lot of travel. Just like you are going to Mumbai. Even I'm also traveling to Mumbai, then Hyderabad, Pune, and back to Bangalore.
Uh-huh.
So for at least give me 4 to 5 weeks window, like then probably things get sorted out and even like it gets streamlined. So maybe then probably I can take some sessions.
Yeah, sure.
Yeah, sorry for that.
Yeah, one of the things that we wanted to learn was other thing was gradient descent. I'll also ask Purnima whether she is ready to present. Mm,
Okay.
and that is one more topic. And the statistics inferential part, I'll ask Adira to present. And
Okay.
if anyone of you is ready to present, that is also fine regarding inferential part or gradient descent. For the or Shivam, do you guys want or Shalini, do you want to present next week? Shalini, you were doing some project, right? Not related to data science, but some project you were completing, right? That you.
Yeah, that actually, I've not completed it. Only
Mhm.
the UI side and backend part was, it's just a simple like full stack application,
Okay, okay.
not related to data science.
Mhm.